Today's lesson is about algebraic equations. Okay, so today obviously I'm not here at school, but we're going to continue our learning on what we're going to talk about today, or anyway, if I was there or not, is on guided notes on page 4. I told you that we were going to do those two problems at the bottom on the right side of the column together, and so here's the video for those two problems. So the first one is 6x times 4x plus 3, and then minus 3x times 8x minus 1, and those are in parentheses, equals 14. Okay. Now remember that this is an equation, so solving is the main goal here. Okay. Unlike yesterday where we were simplifying, there we were just trying to simplify into simplest terms. So go down as far as we can without being able to go any further. So here we want to be able to find actually what x is. So you're going to have equations that just have one variable value. So we just need to find what that value is. But we're going to use those things that we talked about yesterday to help us get those values. So yesterday we had expressions where if you ignore the equals 14 on the right side, we had some of those, especially in the last example and yesterday, if you look at your guided notes. So here we want to be able to do the same kind of thing, except now we're going to just add that solving property to this equation. So here I want to be able to distribute the 6x through and the negative 3x through so that I can see what terms are like. So 6x times 4x would give me 24x. 6x times 3 would give me 18x. Oh, sorry. I'll make that x squared. Remember also, I should have remembered, like we talked about yesterday, both of those have power of 1. So x to the first times x to the first is like taking x to the first plus 1 in the exponent part, so I'm getting x squared. So then 6x times 3 doesn't have an x, so it needs to stay as an x to the first. Now moving on to the second parentheses, I have negative 3x times 8x, so there I have a negative 24. Same thing, x to the first and times x to the first gives me x squared. And then negative 3x times a negative 1 gives me a positive 3x. And that'll still equal 14. Now I want to be able to put like terms together. So here, if I use the horizontal method, it looks like 24x squared goes with negative 24x squared. So I'm putting those in parentheses and grouping them using the horizontal method. And then plus 18x plus 3x, because those are like terms, so I'll put them in parentheses together, which equals 14. Now I can put my like terms together by doing 24x squared minus 24x squared. That turns out to be 0x squared. And then plus 18x plus 3x gives me 21x. Now 0x squared is just 0. And 0 plus 21x is just going to be 21x. Now if you understood that this was 0 up here, you can go straight to this step. You don't need to show that, but I'm just showing you that that's what happens with those values, is that you get 0x squared, and 0 times x squared is 0, which 0 plus anything is whatever you had before. So the 0 just disappears. So now I have a one-step problem left to get x by itself. So I need to divide both sides by 21 because that's what's being multiplied to my x value so that I can get it by itself. So 21 divided by 21 gives me 1. So I'm left with x on the left side. And on the right side, 14 and 21 both have 7 in common. So 14 divided by 7 would be 2. And 21 divided by 7 would be 3. So my answer would be x equals 2/3. Okay? Now the second one, you have something similar, but you have lots of stuff on both sides. Still, I want to be able to simplify and put like terms together and then see what it can solve. So let's look on the right side of our equation and see that negative 2 times 4x and negative 7 I could distribute. So 5x squared is going to be left alone. Negative 2 times 4x gives me negative 8x. And negative 2 times negative 7 would give me a positive 14. Notice on the right side I have no like terms. On the left side, if I multiply the 5x through, I get 5x squared, because x and x would be to the first. 5x times 8 gives me 40x, and then negative 3x, or minus 3x, would be left because I didn't do anything to that. The 5x does not go to the negative 3x because it's not in the parentheses. So now I do have some like terms on the left side, and it looks like I have 40x minus 3x. So if I combine those, that gets me 37x. Okay? Now comes the part where I have like terms on opposite sides of the equal sign. I want to be able to maneuver them so that they are on the same side. So let's deal with our x squareds first. Let's say I move the right side 5x squared to the left side. So because it's positive already, I want to subtract 5x squared to both sides. Okay? 5x squared minus 5x squared is 0x squared. Same for the other side. 5x squared minus 5x squared is 0x squared. Now 0x squared, like we talked about earlier, is just 0, so we can just drop that. Same for the other one. So now notice that I just have two things left that are like terms. The 37x and the negative 8x are both like terms. So I still want to put them on the same side as each other. So I need to move one to the other side. Now because negative 8x is negative, it might make more sense to add 8x to the other side so I can kind of keep positive values going in this problem. So on the left side, 37x plus 8x gives me 45x. Negative 8x plus 8x is 0, so that leaves me with 14 on the right side. And how about I write that for you. Okay, so now I need to get x by itself like we did in the last problem. So 45 is multiplying to x, so I need to divide it to undo that multiplication. So dividing both sides by 45 leaves me with x equals, now 14 only has factors of 2 and 7. 45 has factors of 3, 3, and 5. So there are no like values that you can divide both by, so then my answer is 14/45. And that would be my final value. Okay? So notice that we can get fractions with these, and also you want to be able to maneuver stuff to get your like terms on both sides. First though, make sure that you find if there's a like terms on the same side and combine those to make your problem a lot simpler later on. Okay? Contact me by email if you have any questions during the course of the day. Okay? Have fun.